Periodic table of elements is a tabular display of the chemical elements, which are arranged by atomic number, electron configuration, and recurring chemical properties. The periodic table was discovered by Dmitry Mendeleev, a Russian chemist who lived from 1834 to 1907. He is considered to be the most important contributor to the development of the periodic table. His version of the periodic table organized elements into rows according to their atomic mass and into columns based on chemical and physical properties.
The atomic radius is a measure of the size of an atom. As can be seen in the figures, the atomic radius increases from top to bottom in a group and decreases from left to right across a period. Thus, helium is the smallest element and francium is the largest. Atomic radius plays a vital part in determining the effect of heat. To exemplify, non-metals has greater effect than those belong to the group on the left side of the table. The smaller the atomic radius, the more influence the nucleus has on reactivity. Since the nucleus of an atom contains positively charged protons, it also attracts electrons. Thus, non-metals are known to have greater effect of its opposite on the table. Each group has only one designated number of valence electrons. As you move down a group on the periodic table, the number of positively charged protons and negatively charged electrons increases. However, the valence electrons are added to different energy levels farther away from the nucleus. For example, the elements that belong to the hydrogen group has only one valence electrons, and as we proceed to the next group, all elements which is part of its group has a 2 valence electrons and so on.
Ionization energy is the energy required to remove an electron from the atom, but it is always be an electron in the outermost shell. The electromagnetic force that attracts the electrons to the protons drops off very quickly with distance. So the farther away an electron from the nucleus, the easier to pull it away. Meaning, the ionization energy is precisely the opposite the atomic radius. Atomic radius is from helium to francium, while ionization energy is from francium to helium. Francium is a very large atom with only one valence electron. Will be easy to ionize because the electron is far away from the nucleus and atom. Note that losing an electron means the shell is also gone. However, the opposite corner, which is helium, there is only one shell, so the electrons are very close to the nucleus, so it is very stable. To conclude, the farther the electrons from the nucleus and atom, the easier to ionize, and the nearer the electron to the nucleus and atom, the harder to ionize due to its stableness.
We have 9 groups in the periodic table. The first one is non-metal group. Non-metal group is a substance that does not exhibit such characteristic of metal. These elements have few physical properties in common. It can be formed of gases, liquid, and other are solid. The atoms are generally small and contain relative large number of electrons in their outmost shell. In the presence of other atoms, these non-metallic atoms have pronounced tendency to attract electrons to themselves. Carbon is one of the elements that is included in the non-metal group. Carbon is non-metallic chemical elements in group 14 of the periodic table. Although widely distributed in nature, carbon is not particularly plentiful. It makes up only about 0.025% of Earth crust, yet it forms more compound than all the other elements compound. And the example of carbon is carbon dioxide, which is necessary for the plants.
The second group in the periodic table is alkaline metal. Alkaline metal is the reaction with water forms alkalis, strong base capable of neutralizing acid. One of the elements of alkaline metal is potassium. Potassium, a soft silvery white reactive metal of an alkaline metal group. Example of potassium is banana.
The third group in the periodic table is alkaline earth metals. As you can see in this figure, it is a group of chemical elements in the S block of the periodic table with very similar properties. Shiny, silvery, white, somewhat reactive metals at standard temperature and pressure readily lose their two outmost electrons to form cations with the two positive charge low densities, low melting points, low boiling points. One of the elements under alkaline earth metals is magnesium. Magnesium is an important part of the more than 300 enzymes found in your body. These enzymes are involved in processes that help to regulate many bodily functions, including the production of energy, body protein, and muscle contractions. Example of this is avocado.
The fourth group in the periodic table is lanthanides, generally considered to be elements with atomic number 58 to 71. The lanthanide series is the group of elements in which the 4f sublevel is filled. All of these elements are metals. Cerium is one of the elements under the lanthanide group, which is the chemical element of atomic number 58, a silvery white metal. It is the most abundant of the lanthanide elements, and is the main component of the alloy Mech metal. Example is the cerium metal.
Actinides. They are all radioactive, the heavier members being extremely unstable and not of natural occurrence. One of the elements under the actinide group is uranium. These elements all have a high diversity in oxidation numbers and all are radioactive. The most common and known elements is plutonium through a nuclear reaction. Uranium-35 is a great example.